Okay, we're going to be looking at, this is the class live video for Unit 5 for Science 600B. And it goes over, just kind of reviews some of the different things from chemistry. So I thought I would just go briefly through it. I thought maybe it would help such that when you went through this, then it would be easier for you to make your way through it. As you can see here, they're talking about, let me get my pointer here. Remember from the periodic table, you have a list of all the elements, whether it be aluminum, we've talked about carbon, I think we looked at oxygen and iron, and each one of them has a symbol to represent the element. Now, some of these are kind of obvious, like aluminum, the first and second letter, calcium, the first and second letter. Now, some of them, let's see if there's, the one I'm thinking about is AU. I don't know if they have that on here for gold. Is gold on here? But see, gold is not the first and second letter. It's actually capital AU. And the reason being, some of the names, some of the abbreviations come from the Latin word for the name of the element. A lot don't, but some do. And another thing you'll notice too is if you have just one letter that's a symbol to represent the element, it's always capitalized. And there's a hydrogen, capitalized, nitrogen, capitalized. And what do you notice about the second letter? If there happen to be two letters representing that particular element, the first one again is always capitalized, but the second will always be lowercase. Now let's see, let's continue on down here. Now I'm going to be switching over to the whiteboard just to go through a couple of things here. See if we can do that. Okay. Now here, chemical formulas are written using the chemical symbols. Like most people know that H2O is water. You can see it here. And I thought I would just skip over to the whiteboard for just a minute so that I can kind of demonstrate just some of the facts about using or writing a molecule out and when you have the numbers there. So for example, what if you had, like, let's take the H2O. Okay, so if we have H2O, that's one molecule of water. Now you'll notice I don't write a 1 in here if I'm only talking about one molecule of water. It's just if there's no number in front, you just automatically know that that means one molecule of that, whatever it is. In this case, we have a molecule of water. Now you'll notice that there is there's an H there, so we must have in one molecule of water, we must have some hydrogen, because I see the H there for hydrogen, and I see an O there for oxygen. So we have the molecule of water actually contains two elements. It has hydrogen and it combined with oxygen, which is kind of interesting. Now what does this 2 down here mean? That means that in one molecule, because remember the one we automatically know if it's not written there that means we have one molecule here. It means in one molecule of water that I have 2 atoms of hydrogen, 1 atom of oxygen. Again, you'll notice that we don't put the 1 here. If anything is 1, we don't put it in. We just automatically know that that's a 1 there. Okay, now what if I put a 2 in front of here? Let's make it 2 molecules of water. Now, how many atoms of hydrogen do I have and how many atoms of oxygen do I have? Well, interesting enough, this 2 actually has something to do with this here. So you have to remember that it goes to this. And that 2 actually has something to do with this one here. So if I have a 2 in front of the H2O, it means I have 2 molecules of water, of the H2O. And if somebody said, how many hydrogen atoms do I have? That 2 would go over and you'd multiply the 2 times the 2. I would have 4 hydrogens. me see if I can get this for hydrogens. It doesn't seem to be working really well today for hydrogens. And that 2, actually, remember, not only does it have something to do with this, that we ended up multiplying, this is a subscript, the 2 times the 2. That 2 also tells me that I have 2 oxygen atoms. Okay, so what if I had something like, let's take another molecule, let's erase this one here. Let's see, I had sulfuric acid, a really strong acid here. And that's H. Maybe if we make this a little bit wider, maybe it'll show up better. H, yeah, that'll be better. 2 SO4. That's sulfuric acid, a very strong acid. Okay, now if there is not a 1 in front of it, I know automatically that I have just one molecule of the H2SO4. And what if I put a 3 in front of it? Now I have 3 separate molecules of H2SO4. So if we wanted to know in 3 separate molecules of H2SO4 how many total hydrogen atoms there would be, we'd go the 3 times the 2 here, which means that there would be 6 hydrogens. And that 3 also goes over here to the S, that's a sulfur. So isn't that interesting that in sulfuric acid I have hydrogen, the element hydrogen, sulfur, and oxygen that make up that strong acid. So how many atoms of sulfur do I have? I have 3 sulfur atoms. And then in 3 molecules of H2SO4, how many atoms of oxygen do I have? Well, that 3 also goes for this here. And remember, we end up multiplying. So 3 times 4 is 12. So I actually have 12 atoms of oxygen. Let's see. So remember, let's try another one here. What if I had 3 molecules of CO2? That's carbon dioxide. That's what you breathe out when you breathe out. That means, just to kind of make it even more clear, that I have a molecule down here of CO2. And I have another one, because remember I have 3 molecules of CO2. These are connected. And I have one more over here. So the one in the middle is the carbon. And these 2 on the side are the, let's see if we can actually paint them. These here are the oxygen in here. There's an oxygen there. There's an oxygen. So there's 1 carbon with 2 oxygens, just like up here. 1 carbon atom, 2 oxygen atoms makes up 1 molecule of carbon dioxide. Then I have another one over here. What do I have in the middle there? Those are oxygen. There's that carbon atom here in the middle. And there's another carbon atom. Okay, so that shows 3 molecules of the CO2. Let's just see if this method indeed does work and tell me how many atoms I have altogether. So rather, instead of having just 1 molecule of CO2 right here, we're going to make 3. So there's 1, 2, and 3. How many total atoms would you find of each element in 3 molecules of CO2? Well, remember, this 3 goes for this, and it also goes for this. So altogether, in 3 molecules of CO2, I have 3 carbons. This is what it's telling me, and then we're going to look at our picture and see if we're right. 3 carbon. And 3 times, let's see, the oxygen is, we already have 2 atoms there, so it's 3 times the 2 is 6. So 6 atoms of oxygen. Using my little formula of multiplying that out, let's see if indeed that's what we have in our 3 molecules of CO2 that we've drawn here. Let's see, we have 1, 2, 3. Let me even use this. We have 1, 2, 3 carbons. Yep, so that came out correct when we multiplied the 3 times the C, because we have 3 carbons. And then we went 3 times the 2 that are already there. That's 6. So we're saying that we have 6 atoms of oxygen, did we? 1, 2, 3, 4, 5, 6. Yeah, so that worked out. So this one here is a real good example of showing if I have 3 molecules of something, we actually drew them out separately here. And we can also figure out, either using our formula, how many atoms we have of each element. And we even looked at our picture and tallied them up, and we could see that that worked correctly too there. Okay, so that's what they want you to know with that. Now, let's go back to, if you look down here, this is in your lesson here. See, it looks like we have here's the CO2, so there's a good drawing of it there. Like it says here, if the number 1, if it's in front of that molecule, is always implied, you never write it. But here we have a 3 in front, so that's 3 molecules of the CO2. There's one of them, there's another, and another, a third. Okay. We call the little number down here a subscript. I think I mentioned that before. And this one in front of here, the number, the big one in front, is called a coefficient. So a subscript coefficient. Okay, so let's go down further, see what we have. Then you'll have some questions on it. Do you remember about the electron shells here? Let's go back to our board. Go back to this and erase all this. Let's briefly go over the makeup of an atom. Remember that an atom has the nucleus here in the middle, and then you have the shells, remember, that contain the electrons that are around the outside, and they're represented sometimes by dotted lines, or here's the second one coming around the outside. And this all should be review for you. This is all stuff that you've had previous in your lessons. And let's see. Let's say that we had, remember, inside you have the protons, in the nucleus you have the protons, and you have the neutrons. Remember, the electrons are those negatively charged particles out here. I'll put E, and they vary on number. Remember, in an atom of an element, whenever it's neutral, that the number of protons will always equal the number of electrons. I think from 600A we also talked about the atomic number. What actually makes that particular atom a particular element is the number of protons. If you change the number of protons, you are changing what that element actually is. That's very, very important. Let's see here. Now, they do want you to know what an ion is. I don't know if you remember that, I-O-N. And an ion is an atom that has either gained, so now has an extra electron, or it has lost an electron. Okay, so an ion is when an atom, a neutral atom, either loses one of its electrons, or maybe it'll gain an electron and have an extra electron. Both of those would be examples of ions. Okay, and they're not neutral any longer. Let's see if we can get an example here. If we have an atom of sodium, I could look on the periodic table. And remember, you looked at the periodic table in 600A. And sodium actually if you look on your periodic table, it has 11 protons. And that means around the outside there have to be, for the neutral atom of sodium, it must have 11 electrons. Okay, and this is sodium. And I'll just write the chemical symbol for sodium. It's a capital N little a. All right, now what if, and let's just basically, an atom of sodium has the first shell here. I won't draw it all the way around. Then it has the second shell. Remember, this really goes all the way around, but this is a simple way to write. There's the third electron shell. And if you check it out at first, this one has 2 electrons in the first shell, 2 electrons here in a neutral atom. And the second shell actually has 8, so both the first 2 are full. And then this one has 1. Okay, so here's an atom of sodium, like I said, has 11 of the protons. Remember, the positive charged particles in here. In the first shell around the nucleus there are 2 electrons. In the next furthest one out, going all the way around, are 8 electrons. And in the furthest one out, going all the way around, you see 1 electron. Now, there are many different chemical reactions that could take place. What happens, and if you count these up, look, 8 plus 2 plus 1 is 10, 11. In a neutral atom, the number of electrons equals the number of protons. So the number of negative charges equals the number of positive charges. So that's why that atom is neutral. What happens if I lose this electron? It goes somewhere else. It goes maybe to another atom of another element. It's gone. Okay, so now I'm going to cross this out. It's not there anymore. It went somewhere else. And I'll even cross it out. Better cross it out with this so we can definitely see. It's now gone. Now what do we have? I still have the 11 positive protons in the middle, don't I? Put it down here. 11 protons in the nucleus. Remember, those are all positive. So 11 positive charges. How many negatives do I? How many negative particles do I have now? 8, 9, 10. I only have 10 electrons. And each of those electrons, remember, carries a negative charge. So what do I have more of now? Because I lost one of my negative charge particles, I have one less. I have one more positive charge than I do negative charge. They don't balance anymore. They're not neutral. So overall, because I have one more positive particle than I do negative particle, this is now what we call it an ion. We write it like this. There's one ion of sodium, and I'm going to put a plus charge there. When I look at that, it shows me that that atom lost an electron, and now it's a positive ion. Okay, so we want to make sure that you get in your head straight what an ion is. It's when a neutral atom of any element, that atom can either lose an electron, like we did in our example here, or it can gain an electron. Okay, what would happen? What would be the overall charge if it gained an electron without even putting anything down? Say that was still here. If I gained an extra electron, now I would have more electrons than I had protons. So the overall charge then, if I gained an extra electron, would be negative. So I would write it as if it was this, but with a negative sign. Okay, so you'll want to know those. And then let's go back to our page. We want to go back through, so that's what you're going to be talking about here. It'll talk about the first shell can hold 2, the second shell, the max that it can hold is 8 electrons. So they'll briefly go through that. There's that periodic table. I'm going to put, this was actually covered, we did this for a class in 600A, just on the periodic table. So if you'd like to go over that, for your test, I'll go ahead and put the video for it in with your class live, and so you can feel free to go ahead and pull that up and take a look at that, and it'll give you a good overview of the periodic table. I actually found another periodic table that I like a little bit better. That you find many ways that they've written it up. They're basically the same, but sometimes the colors are different, or sometimes the amount of information that they give in each box, for each element is more than others. So, feel free to go ahead and look at that periodic table video. I think it would help you a lot. pH here now. pH means how acidic or how basic something is. Now let me go back over to here. Let's get rid of this. Oh, let's see, you've probably heard of pH table. You maybe have heard of litmus paper. It's paper that you can put into a liquid to determine if, you know, how acidic or how basic it is. What they do when you put some an acid, if you put an acid in water, like let's take HCl. HCl is an acid here. There's a chemical symbol for hydrochloric acid. It's the acid that you have in your stomach. And you can see that it's made from an atom of hydrogen and an atom of chlorine. So when they come together and they bond, we have hydrochloric acid. Well, if you put that hydrochloric acid into a beaker of water, it kind of dissociates, which means that this part goes off, you know, and breaks apart from this part. Now, depending on the strength of the acid, if you have a weak acid, only some of them break apart. And so you could have some little H pluses floating around in here. Those are called hydrogen ions. You're going to see that in your lesson. Okay? Or if it's a strong acid, it dissociates or breaks apart even more, and you could have a great deal of these hydrogen ions in here. If you have a lot of hydrogen ions, you know, through dissociation of this chemical in water, we call it a strong acid. If it doesn't break apart a lot and we only have a little bit of hydrogen ions in there, we call it a weak acid. So the strength or weakness of an acid depends on the number of hydrogen ions. That's what you're looking for, to tell how strong or how weak of an acid it is. Now, if you have, how about NaOH? Let's take a base. Well, there's sodium hydroxide. Now, it has one molecule of it has one atom of sodium, one atom of oxygen, and one atom of hydrogen, making up that one molecule of sodium hydroxide. If you put that in some water, and if it's a base, which you can tell because of this here, that'll break apart into the sodium and the OHs. So you get the OH, which is a negative charged ion here. Now, the more that breaks apart, okay, when you have a base and you put it into water, and remember this is just one example of a base, the more when you put a base into water, if you have a lot of OHs, it's a strong base. And if you have just a couple that have, you know, you only get a couple OHs because of the dissociation, there's not as much from your base that you put in the water, then it's just a weak base, okay? So the more OH minuses that you have, the stronger the base. So here we have OH. Okay, now we actually have a scale. It's called the pH scale, and it ranges from 0 to 14. 7 is the number in the middle, and 7 we consider neutral. It's not acid and it's not a base. Now, if this is neutral, the further you might get away, say you test a solution, the further you get away here from the 7, the stronger the acid becomes. This is actually a 6, and then a 5, and then a 4, and then a 3, 2, 1. So if I get down here to a 1, if I had a way of testing, which I do with litmus paper, and there are even some machines that'll tell you it even more exactly. If I test a solution and it comes out having a pH of 1, I know that that solution would be a very a very strong acid. If it comes out being a 6, That's a weak acid. It's pretty close here to being neutral. It's just starting to be a little bit acidic. Here we're getting to be a little bit more acidic, more, and by the time we get down here, very strong acid. Now, what would you think would happen if I go the other way? If I have an 8, 9, 10, 11, 12, 13, and there's that 14 there at the very end. Because this is neutral, if I just get a little bit of base, then I'll come out being about an 8. So that's a weak base. I'm going the opposite direction. I have some of those OHs in there. By the time I get down here, I have a lot, okay, of 14. That's a very strong base. That means that that chemical that I put into water, it dissociated a lot, and I have a lot of OH minuses, okay? So strong base up here. Strong acid way down here. But in the middle, and it makes sense if you think that that's neutral. If I go a little bit on the acidic side, okay, I'm a 6. And the further I get away from that neutral, the stronger the acid becomes. Same way this. We're on the basic side now. I'm very close to that neutral, 7. That means it's kind of it's starting to become more basic. And the further I get away from that neutral 7 way down here, if I have a pH of 13 or 14, I'm a very strong base. So for the very strong acid, I've gotten a lot of those H pluses here. For a very strong base, I've got a lot of those OH minuses there. So I hope that helps a bit as you go and start your lesson here, and this is a lesson you'll be going through. One thing, if you did test with litmus paper, it's kind of neat. Litmus paper usually comes in blue or red, and acids can be since they're acids, they burn. Whether it be hydrochloric acid, sulfuric acid, whatever, they can burn you, especially the real strong ones. So what helps me remember when I use litmus paper, litmus paper comes in blue color and it comes in red color. If I have that blue litmus paper and it's blue now, if I put it in acid, acid reminds me of burning, which is red, like you get sunburn, you're burned. So blue litmus paper in acid will turn red. If we have red litmus paper and you put it in acid, it's going to stay red, okay, because red is the acid. Blue litmus paper, if I put it into the base, no change because it's already blue. But if I put the blue paper if I put the red litmus paper into a base, because remember, red is what represents acid, and in an acid it does stay red. That red litmus paper will turn blue. So regardless of the color of paper, if it's blue, whether it stayed blue or it changed to become blue, that would be a what? A base. If I use blue or red, it makes no difference, and it changed, it either stayed red here or it turned red. Red reminds me of burning, which reminds me of acid. So if it's red color because it was to begin with or it changed to the red, that's an acid. Okay, so that's how I remember that. So after you watch this, I want you to give me a call. We'll discuss a couple of these things here together. And it's not a quiz. I never will mark you down, but I do expect you to know some of this. We'll discuss it. We'll talk about if there's anything that you don't understand or that we need to maybe make some corrections on. But that's it. And so then we'll give you credit for this assignment. So thanks for watching, and good luck on your lesson.